All right, so in this video I'll talk about a largely failed prototype for linear motion systems within a CNC machine that I want to build. There's a number of things that I don't like about what I've put together here, but it has been a good learning process. I have tried just about all of the linear systems that I've been able to find and have come across and whatever. Rail system, 12mm rails here. V-groove I've used here. This right here is a 8mm, I believe, linear rail. I've also goofed around a little bit with 12mm, this kind of linear rail, as well as this clamp here came with my 3D printer, and it uses these wheels here to go within these extrusion hollow area here. Talk about each of the things that I've learned about those systems, and some thoughts about how I will improve things in what will eventually be my final, or at least my working CNC machine. So I guess I'll start with just the Z-axis. Well, not just the Z. I guess I'll start with the Z-axis. So here I use 8mm. I think it's 8mm, maybe it's 9mm rail. It's similar to this, similar to what I use here. This one here is actually supported rail. There's two things that I didn't like about it. One is that this part here, it's bolted on through this support thing here. You actually have to be careful to make sure that it actually is tight, otherwise it does move around. Now that's probably overcomable, but the bigger issue that I have with it is that while it has these adjustment screws here, it does not have the adjustment screws on this axis here, the way that this 12mm one does. And that I find is important because it means that while it is tight in this axis, it's not tight in this axis. So I mean, there's a lot of motion going on in here, but even if this thing here is steady, when I press up against this here, I get more motion here than I would like. In particular, because the router is on here, and because a router, you really need to kind of hold it in place pretty tightly. Otherwise, you're going to get a nasty, rough surface as you cut it. That's something that I learned in my Portland machine, for which I already have a video about. So 8mm rails probably are okay if you are just worrying about this axis, but if you're worrying about this axis, then I probably, for this machine, it's not going to stay that way. Alternately, what I will do for the Z-axis here is I have an 8 or 9mm other kind of linear rail here. So here, this one works much better. Let's move some of this stuff here out of the way. So this is a mock-up, of course. It's only connected with one rail, with one of these truck things, I think they're called. My plan would be to have a second one here. This is a 20mm piece of rail. I really only need half that of travel. So if I put another truck here, then I really get some good stability. Because even with just this single one here, there's some movement way over here, but not a lot. I'm very, very pleased with how tight in place this thing is. Now, I understand that there are some issues if you have two parallel rails, that they really do need to be quite parallel. Also, I've seen on some videos from professional manufacturers of this where they show how things really do slide very nicely. This one has, a little bit of friction. But for what I'm doing, I think it's fine. Also, I read somewhere that you can replace the grease, the lubricant in here to really get that nice glide. Maybe I'll try that. I don't know if I need to go that far. It seems at least that it is stable enough, rigid enough for what I need to do. So from the machine here, I would have a second rail here, and I think that together with putting in 2, 3, and 4 truck, it'll be as rigid as I need it to be. So for the Xaxis, that's what I've learned, and that's what I will do going forward. So then the Y-axis. The Y-axis here, playing around a little bit with the V groove bearing. So that's basically what we've got here. These are used in, so the Build Your CNC website guy uses this in one iteration of his machine. It seems to work fairly well for him. MechMate has something like this in how they move things around. I think there one of the important things is that with MechMate, because it's a metal sled type thing, the thing is actually fairly heavy, and as a result you don't have to worry so much about the tightness of pushing down here while also having something on the other end to really pull it in tight. Because what I found is that here I have 2 bearings here. Got another 2 bearings here in the back. Just take it off. Got it kind of going like this. This right here is just basically to hold it in place. This I think would work fairly well. The main thing that I don't like about it is it adds a fair bit of height to everything. Also, getting a tapered edge on this Tbar I think is important. I ended up doing this on my table saw, which is probably not the safest thing for me to have ever done, but there you have it. I think that what the MechMate people do is they have an angle grinder attachment thing that they use to just be able to grind down a piece of steel angle to be able to get this nice surface for the V-grooves to sit on. I think that if you just start with either a rounded or with a squared edge here, it wouldn't really work all that well. So yeah, so that's that. What I really want to do with this axis, so that's kind of the linear rail for Y, but what I really want to do with this axis, what I had hoped to do at the beginning, put this thing here back together. All right. So what I'd really wanted to do is be able to have the spindle actually be in the middle, because of the way that MechMate does. The reason for that is that here, it's easy for small movements in bearings and everything, twisting things going on here, to translate then into movement here. My theory is, though, of course, there's lots of, most CNC machines out there do seem to hang out like this, but my theory is that if I could get the spindle to happen here in the middle, I of course would need to have a gap cut into the middle here, but then I could have it be supported by both sides, and then really keep things rigid and in place. But that hasn't been in the cards so far. I'll have to figure that out. Largely the reason that which that's what I wanted to do here. The reason that I didn't do that is because of the height of all of this here. If I could bring this lower down, which I think I can with linear rails, then I don't have to worry. Then it's because then the thing is, if the spindle is having to then reach way down into the middle of this, then I've sort of sold off this distance and then had to pay for it with the distance over here. So So that's the Y-axis. But again here, mostly I'm trying to share the things that I've learned and where things can go wrong. So X-axis here. Here I've got these two linear guide things here. This right here is simply a piece of 12mm tubing that I just bought at the local hardware store. I did find that it is important that smoothness of this is important. Just the way that I got it straight out of the store, it's not very smooth, and you feel it in the way that this moves back and forth. So some sandpaper to this did help a lot. I think that if this was the precision ground stuff that you can buy, they would be even better. At this point, it slides okay. My original intention was to have it be a belt drive, a GT2 belt drive, as is done in the Ox or the Ox OpenBuild system, or a lot of 3D printers. I think given the amount of resistance that I have here, plus the momentum of the mass of the gantry itself, I think that's not the way that I'm going to go. Actually, I know that's not the way I'm going to go. Instead, I'm going to go with a bearing, which I have one here. Talk about that. When I first started the process some years ago, these types of bearings were expensive. So talking about the X-axis here, using this type of the 12mm rail, the smoothness of the rod does matter. I originally started with this is a rod, a piece of 12mm tubing that I bought at the local hardware store. The way that it came out of the store, it works. Yeah, so here I'm in Germany. In the US, if you use 1/2-inch copper pipe, that will be the same as 16mm rail. If you get some sandpaper or some steel wool and rub it down, then it works out much better. Unlike the Z-axis, it does have these set screws here. And so that does make it adjustable so that you can get a nice, fairly rigid movement here. At first I thought, hey, one side can be supported, maybe the other side won't be, but clearly that is not. Here, let's move this so that you can see it. There is a lot of movement happening here. So I have this other piece of wood here, which really it is simply a kind of a house-shaped piece of wood with sanded off tapers, and those fit into here. If I can get that actually in there. Oh, come on. As I'm monkeying around, there we go. So that works much better. Another thing that doesn't really work so well is to just have sort of the 3-point support of two on this side and then just this side here. There's a fair bit of twisting going on here. I think I really do need this 4th one to go under here. So I guess talk a little bit of other things that I've got going on in here. So the spindle motor that I'm going to be using is a radio control airplane motor. This is the biggest one that I could find. I believe it is $29. That together with the electronic speed controller and a power supply gets it to spin. Of course, if you have, at first I tried just a 12-volt power supply because that's what most speed controllers will accommodate. You don't get a whole lot of spinning going on. I think that with a 24 volt, I believe I got up to about 8,000 RPM, which is still not the screaming speeds that some routers will give you. I've heard numbers as high as 30 or 40,000 RPM, which for the smaller bits, of course, matters. But I think that for maybe 1/8 inch, I'm hopeful that it will work out okay. So basically, oh, right. So it just came with the regular shaft for an airplane. I simply took a hammer and I tapped out the existing shaft. And then I took this ER11, I think it's ER11 collet, and I just tapped it right back in. So didn't need a press. I don't have a press. Just tap, 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 tap. And so then there I have now my spindle. So I'm hopeful that that will work out well. Again, the voltage is the sort of limiting factor of how quickly it will spin. So it would be nice if I could do maybe up to 36. I don't know. I'm pretty sure that my electronic speed controller would not handle that. If nothing else, the capacitors on there, I think, are only rated for the 24 volts. Because then I think I actually could get to a speed that I would like. So that is that. So some of the things that I think I will be successful with, actually, yeah. So here is a piece of aluminum extrusion. This is 2020 from the Motedis. I don't know how it's pronounced. It's a company here in Germany. It's fairly popular, I believe, with hobbyists. A meter piece of 2020 like this, I think, only costs a couple of euros. So you buy, 10 of these or whatever, and you pay the same amount in shipping as it does for the product. And you get some fairly nice product. It's fairly rigid for being the 2020. So that I am fairly pleased with. I have attached to it this 12 millimeter rail. In this case, I have two pieces that are 400 millimeters each. So you can see here, it is actually two pieces. There's this one piece here, that's one piece there. I'm not sure if that is visible. You have to be careful about how you align it here. In fact, when I did that, I basically had the truck sort of straddling in there, and then I fastened those down. If I can get this to work, this is the way to go. I paid $50 for three 400 millimeter pieces and 3 of these trucks. That I think it's worth the cost. So, but there are other possibilities. There's the OpenBuild Ox system, as well as the Delta 3D printers. Use this system. This is one of the brackets from my 3D printer. I bought the linear rail version of it, and it came with these brackets even though I did not need them. A couple things to note about this rail, the 2020. The OpenBuild Ox system uses these little wheels. They do not fit onto here. If the taper on this was like 1 millimeter narrower, or if this slot was 1 millimeter wider, then it would work great, probably. And this stuff does fit on the larger 3030 extrusion, but the cheap 2020 stuff, not going to do it. Instead, you got to have these wheel things. It's the same as what's on here. On the one hand, there's a fair bit of movement here. But when it's in this bracket here, it actually seems to be okay. So if you have a couple of them in a row, top and bottom, could work well. And I think I might try to do something, maybe do a plotter or something with this, where you don't have quite as much forces going on of the router trying to have its freedom to be able to go wherever it wants to in the wood. Yeah. So moving along, I also have another thought about I have a regular old bearing here. It actually fits fairly well into this slot. I think maybe if I were to print a little bit of a collar to go around this, such that it doesn't bottom out, but that it actually is riding on the inside of this slot, I could imagine that sort of in a similar system to this. Have a board, piece of plate with a couple of holes in it to have some of these going like this. There would be a little bit of play up and down here, but kind of like with my MechMate theory, if you have a little bit of weight on there, maybe it's not a problem. It could work, right? I mean, the point being, or the reason I bring it up is these bearings are cheap. This rail is cheap. The linear rails cost a little more. One issue that I did have with really all of these bearing type things is managing friction between the bearing itself and the bolt. At first I tried just having the bolt touch directly against it, but if you have it tight enough to be firm, to be rigid, then the bearing isn't going to turn. I have here a nylon washer, and that actually seems to work fairly well. It's only on one side. I have the same thing going on here. It does give some friction, but it's not so bad that the thing won't move. So last, I'll talk a little bit about linear movement, the ball rail, ball screws. I have one of these. I also have a longer version of that. I like this. This, I think, is probably going to be the way that I go. The ball screw itself with the nut, I think, is like $15. These support things are an additional $15, so $30 per axis. I was really trying to go on the cheap with the router. I mean, this is not my job. This is just me goofing off, having some fun. Do I really want to be spending hundreds and hundreds of dollars on a CNC machine? But I think at the end of the day, you are going to have to spend a little bit. And I think this is probably one of those places to spend some money. So it's fairly rigid. It turns fairly nicely once you get this. Oops. Once you get this bolt here set the way that you want, and then there's a little screw in here to tighten it down to keep it from turning. So once it is a little bit loose, it does turn fairly nicely. Again, it's not one of those things where you turn it spinning and it's like perpetual motion. It just keeps spinning on its own. But it is fairly smooth, at least to my taste. I have seen some reviews out there where people are much more critical of these cheap AliExpress specials. But for where I am and for my level of expertise and all that, I think it'll work out great. I did try to think, okay, can I get a piece of wood and put one of these bearing things in it, you know, the appropriate size, of course, for it, and then kind of makeshift it that way. But I think at the end of the day, I'm going to just buy the support brackets. You only need to attach one end, this end here, although there is a, you put a ring on there. It's mostly just to keep this from whipping around. In my original machine that I'd made in Portland, I used 1/4 rod, and you know, I had a piece that was good 6 feet long. And the thing, when it was spinning, it definitely did a lot of whipping around. I then switched to a bigger one that didn't work. I tried Acme. That also doesn't really work. It does, but I wasn't able to move the gantry very quickly. So that particular one is chain drive, sort of like the GT2 belt drive. But this machine will have an area. If I could get 400 by 800, I think I'd be pretty happy with that. Probably 400 by 400 would actually be fine for most things that I do. I am not a cabinet shop. I don't need to be putting a big piece of full sheet of plywood on there to cut, though that would be nice. In any case, that I think is what I have to share. So hopefully it was useful, and hopefully I'll eventually have a working machine of my own.